You share about 99.9% of your DNA with every other human. Identical twins, emerging from a single fertilized egg, share essentially 100%. Yet no one who has ever lived or ever will live has had your exact fingerprints, not even your twin. This isn't a failure of genetics, it's a triumph of physics. The genetic code doesn't contain a blueprint for the final pattern. Instead, it provides a set of rules for a self-organizing system. It all starts in an embryonic battle space just a few cell layers thick, at the interface between your developing epidermis and the deeper, supportive dermis. Sandwiched between them is the stratum basal, a single layer of stem cells furiously dividing. As the fetus develops, the epidermis grows much faster than the dermis beneath it. This differential speed creates immense compressive stress on that basal layer, forcing it into the only configuration possible to relieve the pressure. It buckles, folding into itself to create the first primary ridges. This buckling is a beautiful example of a physical phenomenon called mechanical instability, but its outcome isn't left entirely to chance. The initial direction of these folds is guided by temporary structures, soft fleshy mounds on your developing fingertips called volar pads. These pads, which appear around week 7 and recede by week 16, act as a physical template. Their unique geometry at the critical moment of buckling dictates the primary pattern. A high centered pad creates a symmetrical stress field, causing the buckling ridges to form concentric circles, a whorl. A flatter lower pad results in a less severe fold, forming a simple arch. And if the pad is asymmetrical, tilted even slightly, the stress field is warped. This forces the nascent ridges to flow around the peak, creating a loop. It's a system where macroscopic shape dictates microscopic patterns, a physical cascade that locks in the first draft of your identity. But this draft is just the headline, the whorl, loop, or arch. The story is in the details. The features that an algorithm or a detective looks for are the minutiae, the ridge endings, bifurcations, dots, and islands. These are not sculpted by the volar pads, they are inscribed by chaos. Between the 10th and 24th week, your developing hands are not isolated. They are bathed in the warm, swirling currents of amniotic fluid. The precise, ever-changing pressure of this fluid creates random forces on the buckling skin. Every twitch of your developing muscles, the brush of the umbilical cord, even the faint rhythmic pressure from your mother's own heartbeat sends micro-pressures across your fingertips. These tiny, unpredictable events act as perturbations, causing a growing ridge to halt, to fork, or to collapse into a dot. Your fingerprint becomes a topographical map of your unique journey through this uterine environment. By about week 24, this process is complete. The volar pads have vanished, their job done, and the layers of skin have fused, locking the pattern in place for the rest of your life. It becomes a permanent physical record. You could suffer a surface-level burn or scrape, and the skin would regenerate following the exact same pattern guided by the template in the deeper dermal papillae. A deep scar can disrupt the pattern, but it merely edits it. The surrounding ridges remain as they were formed. This field of study, dermatoglyphics, examines one of the strangest paradoxes of our biology. That a pattern formed by an unpredictable cascade of physical forces becomes one of the most stable, unchangeable, and personally identifying features of our entire existence. It's an identity forged by physics long before you had a concept of self, a permanent echo of the quiet chaos from which you emerged.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, Thanks for watching.